So here we are with the 2-6 day 1 assignment, and you'll note that it says 3 through 36 by 3s. Of course it is laid out for you, but that would just mean 3, 6, 9, etc. Alright, so we're going to first start in number 3 by finding the domain of the function. So taking a look at our our function, notice there's an x in the denominator, and anytime that we're looking for a domain and we have a denominator, we don't want anything that would make the denominator a 0. So of course there's many ways of doing this. Algebraically, you can just say I'm going to take the x squared minus 4 denominator, set it equal to 0, and see what algebraically comes out. So if we add a 4 to both sides, we get x squared equals 4, or the square root, which actually means a positive or a negative 2. So that means that positive 2 and negative 2, if you square them and subtract 4, you're going to get a 0, which we do not want. So we're going to use limits to describe the behavior of f at these values, because if the denominator does not, gets a 0, that means that we actually have an asymptote at, in this case, x equals 2 and x equals negative 2. If we take the time to graph, and of course you can do this on your graphing calculator, we end up with an equation that looks like this. And so of course right here is our negative 2 asymptote, and right here is our positive 2 asymptote. So if we're going to do the limit notation to describe the end behavior, for the ones that are not in its domain, we need to do the limit as x goes to 2 from the left. We need the limit as x goes to 2 from the right. And then we also need the limit as x goes to negative 2 from the left, and the limit as x goes to negative 2 from the right. So again, the right and left of both of those. And we're doing it of the function. So it's always of the function, in this case f of x. And then the answers are going to be negative or positive infinity. So remember that if we're doing the negatives here, we're talking about the left. So imagining approaching 2 from the left, so left is over here, approaching 2, oh, so that's this one, we're going up. So approaching 2 from the left, we go up, so the answer is going to be positive infinity. If we're approaching negative 2 from the left, we go down to negative infinity. Let's see, if we approach 2 from the right, so these ones are the right direction, that means that we are approaching, in this first one here, 2 from the right. So 2 from the right means we go down to negative infinity. And then approaching negative 2 from the right means that we end up going positive. So again, this is the result that we want, talking about limits to describe the end behavior of f at its domain, at the values of x that are not on its domain. Yikes. Okay, so in the next ones we want to describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function, or that parent function. And we need to identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior. If we have an equation like we have in number 6 in that vertex notation, so you can see that your h is right here, and then plus 0 would actually make your k, so we know where that kind of rotation of the equation is. From here you can go ahead and say that it used to be at 0, 0, but now we're going to be at negative 5 from that h, 0. So really all it's done is shifted left 5. From those two values. The next thing that it also has is this negative out front and then a 2. And so the negative value is going to mean that it flips over the x-axis. And then the 2 means that it's stretched vertically. So, in our graph, ultimately the equation would have been, for the parent of 1 over x, it would have had a little asymptote kind of curve here and a curve here. But again, we are shifting this left 5, so we are going to want, instead of 0, 0, we're going to want to be at negative 5. And it flips it over the x-axis, which means that instead of being up here, it's down. And so instead of down, it's up. And technically, it's going to be stretched more, which would just mean, let's see, that where it intersects is going to be just a slightly bit closer to the axis. So, on that note, if I redraw, again, I don't want these ones because that's where it initially was. And then remember that our new vertical asymptote is actually at negative 5, but then also still at 0. So, we will end up with kind of a stretched version up here, and then a stretched version down here. Again, it's very hard graphically to show these ellipses stretched, so potentially they're just kind of closer to the axis. Okay, so let's see. Horizontal and vertical asymptotes. So we didn't do that yet. So the horizontal asymptote I've kind of already drawn, but the horizontal asymptote is at y equals 0. And we got that from graphing, and the fact that we added nothing for our k value. And then your vertical asymptote is going to be at negative 5, x equals negative 5. And again, that's because of the h value, or the opposite of that h value. Then they want you to use limits to describe the corresponding behavior and sketch a graph. So we already did that. So now we need to talk about what's happening as it approaches that negative 5. So we're going to do the limit as x approaches negative 5 from the left. And then we're also going to do the limit as x approaches negative 5 from the right. And that's of this function, which is f of x. And so that means, oops, this is not really an equal sign, that approaching negative 5 from the left, so left is over here, approaching negative 5 goes up to positive infinity. And then the other one, approaching negative 5 from the right, goes down to negative infinity. And then they do say limits to describe the corresponding behavior for horizontal and vertical. So I am going to do our initial limits, which were, we can actually do both of them. So we can say that the limit as x goes to infinity and the limit as x goes to negative infinity, because they actually equal the same thing, of the function are, notice that as you approach infinity here, it's at 0, and if you approach infinity here, it's also going towards 0. So we've got that piece as well. Okay. So, moving on to our next one here, we have it in kind of a standard rational function notation. So if we want to, we can long divide to get it into a format as we had before. Or we can do what we saw in our notes, where we set the denominator and numerator equal to 0 in order to find intercepts and vertical asymptotes and things like that. So I'm actually going to take the time to just solve this. So I'm going to synthetically divide, since it is a linear binomial with a leading coefficient of 1. So I can take negative 4 from this 4 and divide it into this equation, which I'm going to rewrite as negative 2x plus 5, so that I can put negative 2 and 5 into my synthetic problem. Then I bring down a negative 2, multiply by negative 4 and get positive 8, and then add 5 and 8 and get 13. So that means that the new equation that I can use to write this as is negative 2 plus 13 over the divisor of x plus 4. But of course, if I want it to be in this vertex format, I actually want to rewrite it so that the function is 13 over x plus 4 minus 2. Officially, that means that our h value is negative 4, and our k value is negative 2, and our a value is 13. So, moving to the end of this assignment, if the a value is 13, that means that we are stretching the image vertically by a factor of 12. We also have a h value of negative 4. And so what that's going to do is move our function left 4 units. And then the last one was that it has a k of negative 2, and so we're going down 2 units. And so again, kind of taking a look at what we would initially have as our 1 over x, we do have the image in these two areas, the bottom left and the top right. But if we go ahead and do each of these things, we're going to move this center that was at 0, 0 left 4 units, which means that our new asymptote will be here, and then down 2 units, which means that our other asymptote will be over here. So again, the one asymptote is y equals negative 2, and then our vertical asymptote is x equals negative 4. Alright, so instead of these black values in here, they are going to stay in those general areas in the bottom left and the upper right, but we're going to move them so that they surround this new center at negative 4, negative 2. So the directions also say, let's see, identify the horizontal and vertical asymptotes. So our horizontal asymptote, as I just mentioned, is y equals negative 2, and the vertical asymptote is x equals negative 4. And so we need to do our limits. So we're going to do, for the vertical asymptote, the limit as x approaches negative 4 from the left. And we'll do the limit as x approaches negative 4 from the right. And then for our horizontal asymptote, we're going to talk about the limit as x approaches negative infinity, and the limit as x approaches regular infinity, positive infinity. So taking a look at this first one, the limit as x approaches negative 4 from the left. So over here, as it approaches negative 4, we're going to go down. Alright, next one, as we approach negative 4 from the right, or the positive direction, we're going to end up going positive infinity. Our next one is the limit as x goes to negative infinity. So as we're going towards negative infinity, what are we approaching? Negative 2. And then the last one, as our x's approach positive infinity, the function approaches negative 2. Alright, and then we also have our sketch, so that should be it for that problem. Alright, next one. In exercise 11 through 14, we need to evaluate. And was that it, or did I need to? No, okay. Evaluate the limit based on the graph. So this is our f of x, and we're going to evaluate the limit. So this is red. As you approach 3 from the right. So as you approach 3 from the right, so here we are on the right side, approaching the number 3, what happens? It goes down to negative infinity. The next one is kind of asking the same thing. In number 15, we are asking, as you approach negative 3 from the right, what happens to the equation? And so as we approach negative 3 from the right, it's going to positive infinity. And then the next one says, as you approach infinity, so just positive infinity, you can't really approach infinity from the right because that's impossible. So in that case, as we approach infinity, positive infinity, we are apparently getting to this value here, which based on the diagram says that it's going from negative 5 to 15. So this is actually negative 5, 5, 10, 15. So that means that we're approaching 5 as it goes to infinity here. Alright, next one here, we want to find the horizontal and vertical asymptotes and use limits to describe that corresponding behavior. So again, we can do this by division, but that's only if the powers, which the numerator power is 1 and the denominator is 2, so that one doesn't work quite right. We did also mention in our notes if the denominator power is greater than the numerator power, then your horizontal asymptote is y equals 0. And so because we have that here, we are going to say our horizontal asymptote is y equals 0. And then we'll talk about our limits. So the limit as we approach the right of the function, and the limit as we go to the left, meaning negative infinity of the function. And then we'll have a vertical asymptote, or actually 2, because if we set this denominator equal to 0, you're going to end up with x squared minus x equals 0, or if you factor out those x's, you're going to get x times x minus 1. And so to make this set 0, you need an x of 0. And to make this set 0, you need an x of 1. So x of 1 and 0 are going to be our vertical asymptotes. And so that means that we're going to have to talk about each of these limits. So the limit as x goes to 0 from the left, the limit as x goes to 0 from the right, and then also the limit as x goes to 1 from the left, and the limit as x goes to 1 from the right of the function. So, of course, in order to get this, you could graph it, or you can actually plug in values very close to what we're looking at in order to find out if it's going to be very big or very small. So, for instance, I could plug in, taking a look at this one here, I could plug in an x of, let's see, to the right, from the left. So I could look at negative 0.000001. And that would get me very close to 0 from the left, and then you could see if it's a very small number or a very large number. But sometimes with the calculator spitting out scientific notation, it's hard to see if it's negative or positive. So either way, if you want to plug in values or you want to graph it, of course you can use your graphing calculator to do that. And so just a little snippet of what it looks like. It's kind of weird. It goes like this. There's a little bit of a parabola down here and then over here. So in that case, as we think about just the horizontal asymptote or end behavior, as we go to the right, it's going to go to it looks like 0, so I just want to make sure it never crosses. Yeah, because we have a horizontal asymptote at 0, but anyway, 0. And then as it approaches negative infinity, it's also going to be 0. Alright, then the next piece, we have 0 from the left. So as we approach 0 from the left, notice that we are going to positive infinity, so we're going to want to write that. As we approach 0 from the right, we're going down to negative infinity. Then we have approaching 1 from the left, so that's negative infinity. We're approaching 1, and what does it do? It goes down. And then as we approach 1 from the right, it's going to positive infinity. Alrighty. It's a lot of limits. Okay. Then we want to find the asymptotes and intercepts of the function and graph it. Probably based on what we find. So again, same thing happening here where we have the denominator greater than the numerator. And so because of that, our horizontal asymptote is y equals 0. Then we go through and actually set the denominator equal to 0, because that's going to give us our vertical asymptotes. So in order to do that, we're going to factor x squared plus 2x minus 3. Let's see, negative 3 to multiply is going to have to be positive 3 and negative 1. And so that means that my vertical asymptotes are at negative 3 for that piece and 1 for that piece. The y-intercept comes from plugging in a 0. So we just need to take the entire function and, set a 0 in. Lots of zeros happening. So the numerator simplifies to 2 and the denominator simplifies to negative 3. So that's going to mean that our y-intercept is at 0, negative 2/3. So your x-intercept is going to be at a numerator of 0. The numerator becomes 0 at plugging in a negative 2, so our x-intercept is negative 2, 0. And so now I'm going to sketch a graph of each of these. So let's see, the first thing I have are a set of axes. I know that my vertical asymptotes are at x equals negative 3 and x equals 1. And then my horizontal asymptote is at negative 2/3, so a little bit below the axis. And my y-intercept is at 0, 2/3. Let's see, I'll make that purple. And then our x-intercept is at negative 2, 0. Many ways to fill this in, but hopefully you can at least see that if this is an asymptote here and it's going down this way, you are going to need to kind of follow that pattern. The other two are not as easy to figure out, but you can always just plug in a number. So for instance, if I plugged in a 2, I end up getting a positive number, so I know that we're up here. And if I plug in -5, for instance, I end up getting a negative number, and so I know it's down here somewhere. And of course you can check via graphing as well. One thing to note about the calculator is that it does this weird thing because of pixels where it, depending on which calculator you have, I guess, it graphs it and then it kind of like connects all of it, and so it looks kind of like, I don't know, weird cursive, okay? But again, we have to be a little bit smarter than our calculator there, so. Alright, moving on, we're going to do the same thing in 27 and 30. We're going to sketch them via the vertical asymptotes, intercepts, and horizontal asymptotes. So before I get too far into this, I am going to factor the denominator and numerator if I can. So the denominator can factor into x minus 1 and x plus 1. And then the numerator, and it turns out the numerator is actually unfactorable, but that would just mean we'd use the quadratic equation. So starting out with our vertical asymptotes, that's when the denominator equals 0, so our vertical asymptotes are at x equals 1 and x equals -1. Horizontal asymptotes, when they are equal, we can either use long division to divide, or it's actually the ratio of the leading coefficients. So 2 over 1 means that my horizontal asymptote is 2. Let's see, and then we have, the y-intercept. And again, that comes from plugging in a 0. So our y ends up being a 0 here, 0 here, 0 here. And so -2 over -1, or just 2. And then the x-intercepts is when the numerator is equal to 0. And so we'd actually have, in the quadratic formula, an a of 2, a b of 1, and a c of -2 in order to put it into x equals -b plus or minus the square root of b squared, which is 1, minus 4a, which is 2, c, which is -2, all over 2 times a. And so it's gross, but it's actually -1, add or subtract square root of 17 over 4. Either way, we are just sketching a graph, so we just need to know kind of a rounded decimal for this. And so if you evaluate, you get 0.78 and then also -1.28. Either way, we just needed a little sketch. So, looking through here, we have a vertical asymptote at 1 and -1. We also have a horizontal asymptote at +2. Our x-intercept numerator our x-intercept, y-intercept is 0 and 2. So that means the coordinate of y-intercept, okay, here. And, oh, no, that's not what I meant. At a y of 2. So x is 0, 2, so apparently we intersect right here. And then our x-intercepts are at almost 1-ish. And what was the other one? Almost -1 point something. And I'll end up doing the rest of these on another video, but as you can see, since we get a value down here, we're going to have this piece. We're also going to have this kind of snake-like piece in the middle, and then if you plug in any of the x values over here, you get a positive. So that's over there for our sketch. Alrighty, so the next next pieces will be on another video.